5, good morning. It's Monday morning, and you may or may not be delighted to hear that we are actually going to be doing fractions. Don't panic. You've done it before, you're good at it, and you're going to have lots and lots of practice with different things to help you, so really don't worry about it. Okay, so before we start our fractions, let's have a go at a warm-up of some of the things that we've already done. So I'm just going to give you 5 questions on fractions, things that we have already done before. Now, this was before Christmas, so don't panic if you find it a little bit trickier. You can pause the video, give yourself a bit more time, that's okay. So let's have a look. Question number 1 then. What fraction of the figure, so that's this box here, what fraction of this box is shaded? And you have to find the missing numerators. So for each of these questions, you need to decide is it A, B, C, or D. It's out of 8 because there are 8 parts in total. Okay, here we go. The answer is 3. Can you see 1, 2, 3 parts are shaded, so 3 out of 8 is shaded. Question number 2. Okay, which of the following fractions is the greatest, the largest? So have a quick go. Pause it if you need a bit more time. 3, 2, 1. Okay, hopefully you got the answer, 5, 6. Now, just to quickly explain that for those of you who think that's not quite right. This here, 5/14, means that our cake, because we want to be eating cake, our cake would be split into 14 pieces, and we'd only get 5 of them. This here is 12 pieces, we get 5 of them. This is 8 pieces, we get 5 of them. Here, we only need to cut our cake into 6 pieces, and we'd actually get 5 of those pieces. So here we've got nearly the whole cake, whereas on this one here, 5/14, we actually, we don't have even a half. And the same here, that's not even a half. Okay, next question. Okay, which of the fractions is greater than 3/8? So if I've got something cut into 8 parts and I've taken 3 of them, I need to find one that is bigger than that. So is it 3/10, 3/9, 3/12, or 3/5? I've drawn a little diagram here to help you, just in case that might be useful. Okay, 3, 2, 1. Okay, the answer is 3/5, and the reason being that this is 3/8. So I've got, say I've got a strip of, let's go healthy, let's go a cucumber, and we've cut it into 8 equal parts. If I take 3 of them, that's these 3 here, 3/5, it would be the same length cucumber, but actually I'd only need to cut it into 5 parts, so each of those parts would be bigger, which means that if I've got 3 of those bigger parts, I'm going to have more than I would do if I had 3/8. Right, well done, doing really well. Next question. Arrange the fractions in order. That's not quite written correctly, sorry. Arrange the fractions in descending order. So descending, remember, means going down. So descending order, starting with the biggest fraction down to the smallest fraction. I'm going to let you have a go at that. Pause the video if you need more time. Okay, 3, 2, 1. Okay, so you should have had this answer, D, because 2/3 is the biggest, because actually I've had to cut my cake into less pieces, which means each piece is bigger. And so what I should see is my my denominator will get bigger, and as it gets bigger, the parts are actually smaller, which means that it's getting smaller. Now it sounds really strange, that, doesn't it? But the bigger the denominator, the smaller the piece. Okay, right, next one. So question 5. 3/7 of a jug is filled with orange juice. If water is added to fill an additional 2/7 of the jug, what fraction of the jug is filled with juice now? Go for it, have a look. Okay, 3, 2, 1. Right, hopefully you had B, 5/7. Don't fall into the trap of adding the numerators and the denominators. You only add the numerators, and remember the denominator stays the same. So it's not 5/14, it's 5/7. Great, well done. Okay, let's have a look at today's Maths No Problem. So you need to look in page 272 of your textbook. We have already done, as you know, we've already done some of the fractions unit, so you should, unless there might be one or two of you who are off leading up to Christmas, maybe self-isolating, so you may not have done all of the lessons, but we should all, hopefully, most of us be moving on to lesson 15. Okay, so it's page 272 in your textbook. So pop today's date in your books. Now we've obviously got it in Roman numerals as well. Just checking I've done that correctly. Yes, I think I have. Okay, so we are moving on to multiplying fractions. Now it's not as scary as it seems, I promise. I'm going to show you a way to do it that actually, if some of you will remember doing it already, but if you follow the rule, if you follow the way that we do it, it's actually quite simple. So multiplying fractions by whole numbers. Now another word for whole numbers is integers. So we might come across that word as well. So multiplying fractions by an integer or a whole number. So you're in focus today. We've got a piece of paper here and it's been cut into 4 parts. One part is shaded. And so she says, I used this much art paper. I keep meaning to check what their names are. I have got a picture. I promise next time I'm going to check what their names are. I'm sure you're all shouting at the screen. So she says, I used this much art paper. So she's used 1 part out of 4. So have a think about what that fraction looks like. And then I think this is Ruby, says, I used 3 times as much. Okay, forget this bit for a minute. That's another question. So pause the video and just think, I used this much art paper, this is how much she used, and she used 3 times as much. So how much did she use? I want you to write me down a fraction to show what she has used. So pause now. Right, we are going to leave that part for now, and let's just have a little look at it, okay? Now my friend thinks that 1/4 multiplied by 3 is 3/12. Okay, so that's this here. She thinks that Ruby, I think, has 3/12 because she's got 3 lots of this. And we have a little look at this. Okay, that's what this would look like. She's got 3 of them. So you can see where she's got this from. She's got 1, 2, 3 parts shaded, and she's got 4, 8, 12 in total. But I know that you know that my friend is wrong. So what have I done wrong here? Or what has my friend done wrong here? Let's see if you can jot down what do you think is the problem. Okay. So I'm just going to, we'll go back and we'll have a little look and see what the problem is. So basically, what she's done wrong is she's changed her denominator. So this here shows, oh, sorry about my writing, it's going to look awful because I can't do it very easily using the pen that I'm just drawing on the board. We'll give it our best shot. Okay, so she's used 1/4, 1 out of 4, because that means 1, the line means out of, and 4. Now if she's used 3 times as much, then she has done 3 lots of 1/4. 1/4 plus 1/4 plus 1/4. Oops, gone a bit funny there. Okay, I'm doing it like this because actually if I type it, it doesn't type very well. It gives you a slanty line and it's not how we write fractions. So if I were to add those, which we've done, I would know that my denominator stays the same. So my denominator is going to stay as a 4, and I simply add my numerator. So I've got 3/4. So she's got 3 times as much. She's used this one, and this one, which is 1, 2, 3 out of 4 in total. Now that's by adding it, but when you get into bigger numbers, you'll find that actually you don't want to keep adding. You need to multiply, and we know that from normal adding of whole numbers. When you get into the bigger numbers, you don't want to keep adding and adding and adding on. You want to multiply because it makes it much quicker. So we're going to have a little look at what that actually looks like when we do that. Okay, so this is what we've actually done. We've had a quarter, and we've done 3 times a quarter. 3 lots of a quarter equals 3/4. Now, if we have a little look at that here, 3 times 1/4. I want you just to see, some of you might think, oh, I get this. And if you do, if you're feeling confident, you can move straight on as we do in class. If you get to the point you think, oh, I think I know what I'm doing, you don't have to waste time listening if you're feeling confident. Obviously, if you try and do the work and you think, oh, I'm not so sure, you can come back and watch the video, but get going if you are ready. But for those of you who aren't so sure, let's keep going. So 3 times 1/4 equals 3/4. Now, hopefully you can see, actually, if you look along this line, if we cut this out, cover this bit up, well, that helps, doesn't it? Let's try. Oh. There we go. Okay, if I cover that up, you can see my calculation says 3 multiplied by 1 equals 3. That's perfectly correct, isn't it? We're used to doing that. So actually, that is what we're doing. Our denominator stays the same, and all we're doing is we're multiplying our integer, that's our whole number, by our numerator to create our new numerator. And that is as difficult as it gets. So let's have a little look at this question then. What about if we have fifths instead of quarters? So let's say I have 1/5 multiplied by 7. And what is that equal to? Now notice how last time I had the whole number first and the fraction second. This time I've put the whole number second. As we know, it doesn't actually matter which way round we put our number or our fraction when we're multiplying. So we can put it in either order. So I've done it the other way around this time. So remember, I'm not going to worry about my denominator. So actually what I'm going to do is I'm going to write my denominator in now, because I know it's going to stay as a 5. And then I just simply need to do 1 multiplied by 7 equals 7. Now this time you'll see that actually I've ended up with something a bit different. Hopefully you're saying, oh, I know what that is, Mrs. Hall, I know what that is. That is an improper fraction. Good. So we've got an improper fraction here. So those of you who can't remember that, all that is it means that the numerator is larger than the denominator. So my numerator here is 7, which is 2 larger than my denominator of 5. So what we usually do is we need to then convert that into a mixed number. So the easy way of doing that is we say, how many 5s go into 7? So in this instance, I've got 1 5 goes into 7, okay? And if I take 5 away from there, I'm left with 2, aren't I? 7 take away 5 is 2. So I've got 1 whole, which is the same as 5/5. There we go. Okay, 1 whole, and then I've got 2/5 left over. And if I write that down here, I can have a quick look at that in a moment. Okay, so I've got 1 whole, and oh, the writing on here is not going very well now. That looks like a 1, doesn't it? Let's just correct that. Okay, so I've got 2/5. So 1 and 2/5, which is the same as, so if I put an equal sign there, because these all mean the same thing, 7/5. 7/5 and 1 and 2/5 are the same, because 1 and 2/5 is made up of 5/5 and 2/5, which is 7/5. All right. So we know that when it's 1 whole, the numerator and the denominator are the same size. Right, okay. So let's have a quick look at this. So I've actually answered I jumped on a little bit there. Is it possible to get an improper fraction when we multiply fractions? Yes, it is. we've just talked about that already, so I'll skip on past that one, but you can have a look at that just to make sure you're clear on that one. Okay, so the ones that I've shown you already, this one here, these are called unit fractions because they have a 1 as the numerator. But I'm going to show you what happens when you have non-unit fractions, and that means that the numerator is anything other than 1. So 2, 3, 4, 5, and so on. Okay, so now we've got some non-unit fractions multiplied by an integer. We do exactly the same thing, nothing changes. So I'm simply, you see I've already written my 5 in there because I know it's going to be 5 before I have to do any working out at all. And I'm simply going to do 2 multiplied by 3 equals, and then I'm going to see how many it is. So, well, 2 times 3 is 6. Okay. And then let's have a look at what that actually looks like. So I need 6 fifths. So I've split my whole into fifths. And I need 6 of them. So 1, 2, 3, 4, 5. I've got a little one here, all on its own. It's been left out. Hasn't got anywhere to go. So I'm going to pop it under here, and we can see that we've got 1 whole and 1 fifth left over. So that would be 1, and if I'd need 4 more of those to make another whole. So it's 1 whole and then 1 fifth. Let's have a look at this one quickly. 4 sevenths multiplied by 4. So my numerator is the only thing that's going to change. My denominator stays the same. So I do 4 times 4 is 16. That's right. Well done, guys. Okay, so this time, I've got lots here. So that's 1, 2, 3, 4, 5, 6, 7. Oh, that one's gone on the wrong way. Let's reorder that. Okay, and then you can see that actually that's only 7, and I need 16. So I'm going to need another bar. Okay, which is basically what I did here. Look. Okay, I've got another bar there. So I've got 7 parts. I need to keep going. 8. Oh, look, these are all going to be ordered the wrong way. Let's send that one to the back. Look, no. Love technology, guys. Yeah. Oh dear, never mind. My lines have gone, not to worry. Okay, 1. So that's 7, 8, 9, 10, 11, 12, 13, 14, 15, and I'm going to pinch myself here. 16, is that right? 1, 2, 3, 4, 5, 6, 7. I'm not going to count all those because I know that's 7 again. So that's 2 lots of 7 is 14, 15, 16. So when I put it out like this, I can see that I have got 2 whole and 2 sevenths. So that's 2 lots of 7 go into 16 with 2 left over. Okay, right. If you're still struggling, let me just show you the website. So if you go on Tapestry, there is a link to White Rose Maths. Now, White Rose Maths are great. They've got some really good videos. And if you click on the link, it will take you to this page here. You need to click on this screen here, multiply a fraction by an integer. There's a really lovely lady who explains it probably a lot better than I have just now. So if you have a look on that, if you're still struggling, that will help to explain it even more. And then if you're finding it trickier, you might like to just have a go at this practice sheet here. So you just have to shade in 4 lots of 2/3, so shade in 2/3 on each one, and then you're going to write the improper fraction here, and then you're going to write the mixed number here like we've just done. Some of you might not need to do that, but if you do, that is linked to the Tapestry post that we've done. Some of you might be ready to move on to your guided practice. So page 274. Something to watch out for, guys, you need to be really, really careful of is that you don't this is a little bit confusing, I think, because it's showing you lots of bars. So you might look at it and go, oh, I need to work out the total of all of those bars. Remember, your denominator doesn't change. So it's just showing you that that's 5 lots of this same thing here. But your denominator is always going to be a 7. So you're just looking at the shaded parts, okay? But use the method. And if you want to do some drawings just to help you, just like we've done, that's great. Do that, okay? Then your workbook, that's page 151. You've only got 1 page today, so it's not too difficult. Same with this, though, don't get confused by those drawings. Right, and then your extension. I've saved this link on Tapestry. So this is a link to a little quiz, a bite-sized, BBC bite-sized quiz. So multiply unit and non-unit fractions. I don't really know where it's gone, but hey, when you click on it, it will be there. And then some of you, certainly the Maths Teasers group, should be moving on to this, and some of the rest of you might like to, as there's not a huge amount to do in your guided practice and your workbook today. You can have a go at moving on to this sheet here, and I've popped the answers on to Tapestry as well. Okay, so that's your lesson for today. Have a great time doing it. Just remember, fractions, it's one of those things that adults go, oh, I hate fractions. I hated doing fractions when I was at school. Don't listen to them. We love fractions. Fractions are fine. Just follow the rules and then we'll get there, okay? Key thing to remember, the denominator doesn't change. You need to make sure that your denominator stays the same. Okay, have fun.